Hey everyone, thank you for checking out the video today on function notation and the difference quotient. Let's start with function notation, and let's even go back a little bit further and just remind ourselves what a function is. Okay, a function, remember, is a relation where every input has exactly one output. So that's what we're going to put here. What is a function? A relation where every input has exactly one output. So when we say y as a function of x, what we really mean by that is that y is the dependent variable and x is the independent variable, and y depends on x. And of course, it doesn't have to be y and x. It could be any letters, but we're very used to using y and x, as y is the dependent and x is the independent. Okay? So our first example here says, which of the following equations represents y as a function of x? A little hint there says, solve the equation for y and determine which equation fits the definition. So the first one, if we solve this for y, we're going to get y equals 1 minus x squared. All right, if we think about that, that's just going to be a parabola that opens downward. And if we want to draw a quick sketch of that, I guess we could. Moves up one and opens downward. It's going to look like that. But we don't need to know the graph in order to know this is going to be a function because there's no x value that we could put in here that's going to give us multiple y values. Okay? So every x value we put in here is going to give us a different, only one specific y value, not two y values, not three y values. Every x value is going to get one and only one y value back. Okay, so this one, yes, this is a function, number one. Number two, if we solve this for y, so first thing we would do is add x over to the other side and get here. If we solve it for y, we're going to take the square root of both sides. And remember, square root, technically, we should be doing plus or minus root this side. So when we put an x value in here, let's say, for example, we put 1 in for x. So when x is equal to 1, y is going to be equal plus or minus root 1 plus 1, or root 2. So it's going to be plus root 2, but also minus root 2. So this input is going to give us two outputs. And in fact, that's true for pretty much every x out there. Okay, every x that works in this. So this would not be a function because there's at least one input where we get two separate outputs. Function notation, we denote a function with a letter that represents the name of the function and then the independent variable inside of parentheses. So we say f of x, where f is the name of the function and x is the independent variable. Or g of x, or h of x, or p of x, or y of x, or it could be anything. It could be b of x, or z of x, it doesn't matter. It doesn't have to be x, it could be t. So it could be f of t, g of t, h of t. These letters don't matter. We just want you to know that the letter outside is the name of the function and the letter inside is the independent variable. So this says to evaluate the function. Okay, evaluate just means take the number that we see there and put it everywhere we see the independent variable. So g of 2 means we're going to put 2 in everywhere we see an x. Okay, and that's going to be simplified down to negative 4 plus 8 plus 1. So g of 2 is 5. And what does that mean? That means the point 2 comma 5 is on the graph of g. All right, g of negative 3. So g of negative 3 would be negative 3 squared plus 4 times negative 3 plus 1. Okay, and that's negative 9 minus 12 plus 1. So g of negative 3 would be negative 20. Again, that means that the point negative 320 is on the graph of g. G of t, don't let that scare you. That just means we're going to put a t everywhere we see an x. So it's going to be negative t squared plus 4t plus 1. And there's really no simplifying we can do with that. I mean, I guess we can get rid of the parentheses, negative t squared plus 4t plus 1, but that's it. That's going to be g of t. And finally, g of x plus 2. So everywhere we see an x, we're going to put an x plus 2. So negative x plus 2 squared plus 4 times x plus 2 plus 1. But we do got a lot of simplifying to do here. All right, so we have negative x plus 2 squared, remember, is x plus 2 times x plus 2. So if you need to write that down, you can. So x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4. Distribute the 4, so plus 4x plus 8 plus 1. Distribute the negative, so negative x squared. 2x and 2x is 4x, so minus 4x minus 4 plus 4x, and then 8 plus 1 is 9. And one more simplification step. Negative x squared. Negative 4x and 4x cancel, and negative 4 plus 9 is plus 5. So g of x plus 2 is negative x squared plus 5. Which brings us to the difference quotient. The difference quotient is a very, very important formula, I guess you can call it, for something that we get to when we reach calculus. Okay? Now you're going to do it again in pre-calculus, as we are here in Algebra 2, but when you get to calculus, you're going to do something very important with it, which leads us to a lot of quick ways to find very specific answers. But for now, we just got to learn what the difference quotient is and how to find it. So difference quotient is going to be f of x plus h, where h is some arbitrary number, we don't know what it is, minus f of x all over h. It's just a slope formula. That's all it is. What do I mean by that? Let's do a quick sketch over here. All right, if I draw some random graph, I put one point on there, and I call that point x comma f of x. And now I go a little bit further to the right. I don't know how far to the right. I put another point, and I say this distance right here is h. Then this x value would be x plus h, which means this point would be x plus h comma f of x plus h. So the difference quotient is just the slope between those points. y2 minus y1 over x2 minus x1. So if we wrote that down, it looked like this. F of x plus h minus f of x over x plus h minus x. And what happens is the x minus x cancel, and we're left with that, and that is what you see over here, the difference quotient. So the difference quotient is just the slope between a point and another point that's h units away from that first point. So how do we find it? First, let's find f of x plus h. To do that, we're going to put x plus h where we see x. There's only one x there, so that's x plus h. If you simplify that, we get negative 2x minus 2h plus 4. All right, there's f of x plus h. Then it says evaluate that minus f of x. Okay, so f of x plus h. Sorry, can't remember writing sometimes. That's a 4. F of x plus h minus f of x. And if we simplify that, we're going to get negative 2x minus 2h plus 4 plus 2x minus 4. The negative 2x plus 2x cancel out. The 4 minus 4 cancel out. We're left with negative 2h. So, divided by h is our next step. Negative 2h over h. We get negative 2. Therefore, the difference quotient is negative 2. Well, we could have figured that out without doing any work. What did I say the difference quotient is? It's just the slope. What's the slope of that line? It's negative 2. There's our answer of negative 2. However, we can't always just figure it out by looking at it. And that's why we have to go through these steps. The only reason why we're going to do that one, we could do that one without all the work, is because this is a line, and we know the slope of that line. However, this is not a line. So the slope of this is not going to be some number. It's going to be some type of relation, some type of equation. So we have to go through our difference quotient. All right, I'm not going to do this in 4 steps like we did in the last one here. I'm going to do this all in one expression. So first, I'm going to put x plus h everywhere I see an x. So x plus h squared minus 4x plus h plus 7. That is f of x plus h. Put that all in one big bracket here. So again, f of x plus h is all this. Okay? And now minus f of x. F of x is just the original equation here. So f of x is all this. Over h. And that's it. Now, there's a whole lot of algebra that we have to do. But that's okay. We are ready to do our algebra. Okay, so x plus h squared. That's going to give us x squared plus xh, which is plus 2xh, plus h squared. Minus 4x minus 4h plus 7. Distribute the negative sign here. Minus x squared plus 4x minus 7. All over h. Now, lo and behold, what happens? X squared minus x squared cancel out. Negative 4x plus 4x cancel out. 7 minus 7 cancel out. What are we left with? 2xh plus h squared minus 4h all over h. And I can tell you right now that if you get to this step and every term in the numerator does not have an h in it, you did something wrong. But luckily, all 3 of these terms have an h in it, because our next step is going to be to factor that h out. Because then we can cancel h with h, and that leaves us with our final answer of 2x plus h minus 4, and that is the difference quotient. There are 2 more problems on the next slide that I would like you to pause this video at this point, try on your own, and then you can come back and check your answer. You can also check the key that will be posted on Schoology for the answers to those last 2. But go ahead and pause this video right now, try those 2 problems, come back when you've tried them. And here are your answers to these last 2 problems. Thank you very much for checking out our video today on the difference quotient. We'll see you again soon.